All right, everybody. So today we're going to be talking about 6.1, and for this assignment, we're actually going to work on a worksheet as opposed to working out of the textbook. And so hopefully, when you look at the homework assignments, I've fixed that. Let's fix that right now, so I don't have any issues later. We're going to say worksheet. And so you'll see the worksheet, it's in chapter 6 there. Let's cross it out on both of them. And write worksheet. Sorry, I probably should have done this ahead of time, but we're going to be working on a worksheet today instead of working out of the textbook. And the basic principle that we need to deal with today is that when it comes to square roots and things like that, like the square root of x, or maybe even the third root of x, things along those lines, we have to come up with a way that makes sense to write those radicals, is what these are called, in maybe a better way, or maybe a different way. One of the main problems is the fact that when I go to put the cube root of x in the calculator, from calculator to calculator, the way I do that is different. And there's a lot of frustrations that can come from that. Also, some calculators just don't have a good functionality with tools like this. And because of that, we sometimes want to talk about how do we solve these radicals, is what they're called, maybe algebraically in a way that makes sense to us. And so what we want to do is start with this idea, that if I square a square root, I get x. And if I cube a cube root, I get x. Now these would both be x to the first. So the question is, what exactly does a square root mean in terms of this exponent of 2 or this exponent of 3? Because somehow these guys are canceling each other. Well, let's go back and look at it from a different perspective. Imagine that the cube root was something I didn't fully understand. But I do know that if I cube a cube root, I somehow get x to the first. Well, we learned back in chapter 5 that if you ever have like x squared and it's to the 4th power, that this is the same as x to the 8th, because this 4 will multiply by the exponent 2 to produce x to the 8th. So the same can be said here, that if I'm cubing something, I would be multiplying 3 by its original exponent. So the question is, what exponent would I put there so that when I'm done, I get x to the first? Well, 3 times something has got to produce a 1. Well, if we ponder that question just a little bit, it should occur to us that if I used an exponent of 1/3, that 3 times 1/3 would give me 1. So let's see if this idea plays out in a couple of other examples. For instance, what would a square root be? Well, a square root by assumption has a 2 in the root instead of a 3 or a 4. It's assumed to be a 2. So would x to the 1/2 squared, would that also produce a 1 for an exponent? The answer is yes. Let's take some examples in a calculator that we already understand really well. Let's say we take 9 and we want to take the square root of 9. We know the answer to that is 3. My claim is that a square root symbol is the same as a 1/2 exponent. So let's test it out and see what our calculator has to say. Let's get that cleared. All right. If we take 9 and we raise it to the 1/2. You could also use 0.5 here. Whoops. I missed my 1. Oh, because this thing, my picture's in the way. All right. 1 divided by 2. I get 3. So the claim that we're going to make here is that anytime we have a root, okay, let's say we have a root of, we'll call this m of x, it's the same as x to the 1 over m. Okay? So whatever number goes there, we can write it as the denominator of an exponent. All right, so this is all in the exponent work that we're doing here. And this can be done in reverse. Now, that's great if it's a square root or a cube root, but what happens if we've got multiple things going on? For instance, what happens if I'm taking the cube root of x to the 4th? Is there another way to write this that makes a little bit more sense, or that's maybe just easier to put in the calculator? Because you're going to have to cube root, well, maybe we could write this as x to the 4th raised to the 1/3, right? I mean, a cube root is just an exponent of 1/3 put on top. Well, based on the rules we used in 5.1, we learned that, hey, this exponent can multiply down, producing x to the 4/3. So when we look at these two right here, these are really the link that we want to use going back and forth from what's called radical form to rational exponent. Rational meaning fractions, rational exponent. Rational exponents are actually much easier to put into a calculator. That's one thing that they're good for. The other is when we start to do algebraic reasoning beyond Algebra 2, pre-calculus, calculus, man, these exponents are going to be a lifesaver. You're going to love having a fractional exponent as opposed to a root, which would make your life much more challenging. And so this idea, this identity that this works is really, really critical and fundamental. So let's just look at a couple problems from the worksheet. Okay, it says write each expression in radical form. So for instance, let's take this number 7 here. I'm going to put it in a root. I'm going to put the 7 there. The denominator is always the piece that comes out here in the root. Now you can write the 4 on the 7 directly, or cube root of 7 to the 4th power. Both of those are equivalent and have the same value. Totally up to you. Typically we like to write it with the exponent on the outside, just because if I have to reduce a number or make a number grow, I want to reduce it first. So we usually like to apply the root before we do the exponent. So can we do that in reverse? Well, let's take a look at number 7 here. Our base number is going to be 10. But what exponent would I have put on that deal? Well, remember, out here is where we find the denominator. And since there's no number written, we assume that it's a 2. So that's the bottom of my fraction. And whatever number's out here becomes the top. Over here on number 8, there's no number, so we're going to assume that it's going to be a 1 that's on top. Okay? Other rules that we need to think about. Negative exponents. We learned about this back in 5.1. When you have a negative exponent, that means it's going to need to go to the denominator. In other words, we're going to have 1 over 5x to the positive 1/2. Well, then I still have to turn the 1/2 exponent into a root. 1 over a 1/2 exponent is the same as a regular square root, and I'll dump the 5x in there. All right. Keep cruising on down. There's a 3/2 exponent. I had to scratch out and write a new one. Write them in exponential form. So this would be the same as 6x in parentheses raised to the 4 over 3. This is really all you're going to do. When you see it in the denominator down here, keep in mind your exponent, this is 3k to a negative something. I'm going to leave that empty, but it is a negative exponent that we're going to use because it came from the denominator. This last stuff, yeah, it'd be nice if you remembered that this is just a square root and therefore the answer is 3. But some of these you're going to have a little bit of a harder time. Like 36 to the 3/2. Might struggle with that a little bit. Well, what usually works best is if we just turn it into a radical. See, if I'm doing it by hand, a radical is going to be much, much easier than if I'm doing it in the calculator. If I throw this in the calculator, I can get the answer. But if I want to reduce this by hand, which is kind of the goal here, to better understand it, I really want to do as much of it in the radical as I can. For instance, do you guys know the square root of 36? Well, that's 6. Can we cube 6? Well, I might not be very good at it in my head, but I can use my calculator for that. So you'll use your calculator some, but try not to just throw things in the calculator. Although this could just be thrown in the calculator. Turns out to be 216. Let's look at one more example. Let's look at question number 32 here. Okay, this is really a fundamental idea. Okay, there's two different ways we're going to talk about it. Let's start with the first one, which is just to make it a square root. A 1/2 exponent is a square root of 81 m to the 6th. Well, we know 81 actually has a square root. The square root of 81 is 9. And now I'm left with this square root of m to the 6th. Remember that a number is a square root if it has a number times itself that produces that number. And so, is there a way to multiply and create m to the 6th by using the exact same thing? For instance, m times m is m squared, so m is the square root of m squared. Well, since m cubed times m cubed is equal to m to the 6th, the square root of m to the 6th would be m to the 3rd. That can be very, very puzzling to kind of think your way through. So I want to give you another approach. We're going to distribute the exponent to both of these. This would become 81 to the 1/2, because 81 didn't have an exponent, so it's a 1/2. And that is the square root of 81. And we know the square root of 81 is 9. But this whole time, it's been multiplied by whatever this m is. Well, 6 times 1/2 is 6 halves. And 6 halves reduces to 3. So numbers, when we're talking about numbers, it's good to think of them in terms of a root, to work the root part of it down. However, the variables, it's much easier if you just multiply and look at the exponents for reduction, okay? Hopefully that'll get you through enough of this that you'll feel comfortable to ask questions when you come into class. The answer key is directly below it. I mean, if all you're going to do is copy down answers, I guess that's what you're going to do. But it's really about puzzling through this and asking yourself, what do I understand and what do I not understand? Well, good luck, guys. We'll see you in class, and hopefully we get some good questions out of it as we go into coming back from Thanksgiving. I know this is a remote Friday assignment, so hopefully it doesn't ruin your Thanksgiving. But have a good Thanksgiving, and look forward to seeing you guys back after the holiday. All right, good luck.